Palo Alto Networks CEO Arora recently claimed AI pricing needs to drop 90% because token costs are skyrocketing. While his diagnosis of the pain is correct, his prescription waiting for vendors to lower rates is a trap that will bankrupt scaling startups. The real bottleneck isn't cloud provider greed, it's software architecture. Current systems waste massive amounts of compute on inefficient inference, driving demand beyond what hardware can economically supply. To cut costs by 90%, engineers must stop treating GPUs as infinite resources and start designing for hardware efficiency through quantization and distillation. This video explains why the cheapest AI model isn't a new chip from NVIDIA, it's your own code optimized to run on less of them. The first thing you need to understand is that we are operating in an era of massive inefficiency. A study by Bonn University and Hugging Face reveals that current compute-heavy architectures suffer from low Model FLOPs utilization. In plain terms, this means most modern systems operate at roughly 20% efficiency. That implies 80% of the expensive GPU power you pay for is wasted on every single inference run. If we can improve utilization to just 60%, which is a realistic engineering target, we could reduce the number of GPUs required for a single training run by nearly 70%. This directly addresses Arora's call for lower costs without requiring any change in vendor pricing models or waiting for new supply chains to open up. Consider the physical reality behind these numbers. Training frontier models like GPT-4 requires between 1,700 and 8,800 NVIDIA A100 GPUs, depending on efficiency regimes. This process extracts approximately 7 tons of toxic heavy metals, including copper, iron, tin, silicon, and nickel per run. The hardware itself is roughly 90% base metals. The cost isn't just electricity or rent. It's a massive material extraction bottleneck that physical supply chains cannot easily expand to meet demand spikes. When your code runs inefficiently, you aren't just burning money on cloud bills. You're driving up the global demand for rare materials and energy at a rate the planet struggles to sustain. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This waste is not accidental. It is often baked into how we pay for compute. Researchers from UW-Madison in an Agora study identify a price-performance disconnect that forces bad engineering choices. Cloud providers charge by the hour, regardless of whether your workload is actually using the processor or if it is stalled waiting on memory bandwidth. As memory bandwidth becomes more expensive relative to raw floating-point operations per second, this time-based pricing incentivizes inefficient usage patterns and mixed hardware clusters that hinder software compatibility. Essentially, you are paying for idle time because the billing model rewards keeping machines running rather than finishing tasks quickly with optimized code. This structural flaw in cloud billing forces engineers into suboptimal architectures just to fit within hourly budgets. You might keep a massive model loaded on high-end GPUs even when it is doing little work, simply because turning it off and restarting later feels more expensive due to the fixed overhead of session management or cold starts. The result is a feedback loop where inefficient usage drives up demand, which in turn validates higher prices, creating a cycle that Arora correctly identifies as unsustainable but cannot fix with price cuts alone. The trajectory for this problem is stark if we do not change course. Data from Epic AI and Stanford University shows training costs for frontier models have grown at a rate of 2.4 times annually since 2016. GPT-4 cost approximately $40 million to train, while Gemini Ultra is estimated at $30 million. Without architectural shifts, single-model runs are projected to exceed $1 billion by 2027. This makes the current spend more trajectory unsustainable for anyone but hyperscalers with massive capital reserves. For professional teams and startups building products on top of these models, a 90% reduction in cost is not an option. It is the only path to profitability as usage scales. The solution lies in shifting from brute force inference to hardware-efficient architectures. This means adopting techniques like quantization, which reduces the numerical precision of model weights without significantly impacting accuracy, and distillation, where you train smaller models to mimic the behavior of larger ones. These methods allow practitioners to achieve 90% reductions in GPU requirements today, independent of vendor pricing strategies. If your AI stack relies on running massive models at low utilization rates, you are the primary driver of cost inflation. Optimizing for hardware efficiency isn't just a sustainability win, it's the only viable path to scaling profitably in an era where cloud GPU costs are rising faster than Moore's law can deliver performance gains per dollar. The takeaway is actionable. If your engineering team is not measuring model flops utilization, you are likely part of the cost problem rather than the solution. The 90% drop Aurora wants won't come from vendor pricing tables. It requires shifting to designs that respect hardware constraints through quantization and distillation. Engineers must stop treating GPUs as infinite resources and start designing for efficiency. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.